All right, new one. We spent 3 days on reflections. So let me review it real quick with you. A symbol, the notation for reflections. I look at a problem and I see this notation or symbol and I say a reflection is going on. What is the symbol or notation I am talking about here? 21. Thank you. Use your big boy word, lowercase. Yep. A lowercase r with a subscript telling me what line I'm going to reflect over. All right. Sorry to break the bad news so early here, but there's actually 3 different ways I could recognize a translation, which a translation, again, is sliding up, down, left, and right. Okay. First way to recognize is called function notation. It looks like this. You're going to have xy with an arrow, and then in the second parenthesis, it's going to tell you what to do with xy. So in this case, I'm going to put x plus 2, y minus 3. Can you guys guess in words now, what am I doing to a point or a figure if I go x plus 2, y minus 3? How do you think I'm going to move it? Okay, I need more than over, though, because that could be this way or that way. Right 2, oh boy. Right 2 and down 3. Good. Okay, that's what that's telling me. A translation is happening. It's called function notation. Second type of notation is called vector notation. Looks like this. Those are not supposed to be parentheses. All right, I don't even know what to call those. Chompers? I don't know. Mouths? I don't know. Okay, what am I asking you to do here now? Move every point where? In your own words. It's an X now. Right 4 and down 6. Good. And then there's a third and final notation that has no name for it. I'm sorry, it has no name for it, so I just called it other. Instead of lowercase r here, we're going big T. Big T for Dylan, capital T, uppercase T for the rest of us. Okay, every year I get criticism. I'm sorry it's got fangs, that's how I roll. Okay, that's how I draw my uppercase T, with the fangs. And then along with it, you'll see a subscript. Where am I moving here now? Left 2, up 2. Okay, so there's 3 different ways you could recognize a translation, and I'm going to have you write it all different ways as well. All right, first one here. I got square ABCD and square A prime, B prime, C prime, D prime. Is this a translation? Well, let's find out. Everyone, right now, from A to A prime, figure out how I get there. And I'm asking you about a translation, so you should say, I'm moving this direction on the X and this direction on the Y. So everyone find for me right now, what's my movement from A to A prime? Okay, give me directions in your own words. 18, give me directions from A to A prime. Right 6, down 3. Everyone agree? If this is a true translation, right 6, down 3 should apply to B, C, and D. Check it out. If I go right 5, down 2, not a translation. All 4 points do I move in the same direction. Right 6, down 3. What do we see? Yeah, yep. So this is going to be a yes. And why? All points move in the same direction and distance. Describe the translation. Okay, I'm sorry, it isn't. I know it's honors, but that's not the reason I'm doing this. I want it in all three notations right now. Okay, so here we go. Function notation. XY went to. How do I write right 6 down 3 now? Right 6 down 3. Little help. Little help. 1, 4. Little help. Good. Plus 6, y minus 3. Good. Vector notation. What numbers should go in my vector now that represent right 6 down 3? 25. 6 comma negative 3. Nice job. And finally, the other notation with our capital T. Looks like my kindergarten daughter did that. What's my subscript? 7? There you go. Okay. So it's only a translation if I move the same distance and direction on all points. All good there. Feel like this is going to be a good day for you. Not yet. All right, let's do some translations now. ABC, go ahead and graph it, and then we got to do a little something in vector notation. Okay, graph triangle ABC and its image along the vector. All right, I see the word vector. I know I'm talking about a translation now. All right, if you want me to graph it along this vector, I got a translation. Somebody let me know. -4, 1. Where am I moving all the points? -4, 1. Where am I going to ask you to move all the points? 1, 2, 12. There you go. Go ahead, everyone. Left 4, up 1. Graph it, and then I'll ask somebody A prime, B prime, C prime. Left 4, up 1. Oh, how about I go up 1? A prime, B prime, C prime. Let me know when you're ready. Oh boy, 5s. Here we go. -2, 2. Got it. Okay, you're 2 for 2. Don't screw it up. Good. Quick question, honors kids. Do you need a graph to do this? No. Simply, what can you do here? To every x, subtract 4. To every y, add 1. Yeah, you don't need a graph to count left 4, up 1. You can just add them together. All right, another one. Triangle ABC once again. This one gets a little bit more involved at the end. All right, we had this other notation now. The other one, capital T, says translation. Where are you moving all the points on this one? In words. In words. 24. Where are you moving all the points on this one? Okay, everyone go ahead. And then I'll ask somebody A prime, B prime, C prime. It does say graph and state the coordinates, so I'll do that. After I move them, write 3 down 1. When you're ready, how about those new coordinates? 19. Darn right it is. -1. There we go. 2 for 2. You know what that means? Got it. All right. This has been pretty easy so far for you today. Now here comes the new stuff, part C. Draw me a vector that defines this translation. All right, first thing, what's a vector? All right, what's a vector? It's an arrow. Okay, it's an arrow. Okay, but it serves 2 purposes. Okay, the arrow, the vector serves 2 purposes. Number 1, it shows you the direction we're going to slide. So see my arrow up here? If I had a triangle, I would slide it this direction, going this way. Good? So it shows you the direction, and it shows you, number 2, the distance. However long the vector is, that's how many units you slide it. Okay? So again, a vector, basically a glorified arrow, but it has 2 purposes. It's going to show me the distance I slide it and the distance. However long the arrow is, that's how long I'm going to slide for. Okay? So how do I do it here? How do I make a vector that shows I went right 3 down 1? Easiest way to do it, point A. You went right 3 down 1 and got to where? Okay, so that might be the easiest method, is take A and go to A prime with your vector. That shows I went this direction, that distance. Okay? Do you have to do it on a pre-image and an image? No. You want to get fancy and show off in front of your friends? You can pick a random point. Doesn't have to be on the actual graph, and go right 3, 1, 2, 3, down 1, and make an arrow out of that one. Okay? It can be anywhere on the graph. All right? But again, the purpose of the vector is to show me where I'm sliding and how far. We all right on vectors? All right, because tomorrow, here's what I'm going to do tomorrow. Not that. I'm going to give you one job. I'm going to give you a triangle tomorrow with a vector and say, construct the new one. So you need to slide it this direction, that many units. Okay, that's what we're going to do with the compass tomorrow. Do you have any questions here? Because now it's going to get it's not going to get really challenging, but some of you may get stuck on this next one. I'm going to have you guys work with each other here for a couple minutes. So I did a translation. I started at 3-3 and went to 6-1. Can somebody tell me, I'm just going to use that other notation, what I did? I went from 3-3 to 6-1. Tell me my movement, please. Tell me my movement. 3-3 to 6-1. 21, what did I do? Oh, hey. That's me. So how do I show that? Right 3. What should my subscript be for this one? Right 3. 3, and then what did I do on the y's? -2, I went down 2. All right, so that was my rule. Use the same translation. Find the, pre-image. So I started with this point. I went right 3 down 2. I ended up at 8-3. What was my starting point? My pre-image. I ended up at 2, -5 by using this rule. What was my starting point? The preimage. If you haven't done so already, go ahead. If you want to take a peek at what people around you are doing, just to make sure you guys are on the same page, you can do that. But I'm looking for the starting point. I ended up at 8, 3, and 2, -5. Where did I start? All set? Let's go. Oh, 6. I started where to get to 8, 3? 5, 5. Good job, Michael. Issues? Uh-oh, not me, not me. 9. I started at what to get to 2, -5? Why are you conversing? Like, shouldn't this just be your own? So what's my final point here? Thank you. Everyone all good? Yes, we're set. All right, last problem here. One of my top 5 of the year. Anybody remember my other top 5 last unit? No, Big Al, no.
Oh, no, the mirror.
No, that was pretty good. I don't know if, did I call that top 5?
Yeah, you did.
Did I?
Or maybe you called that top 10.
Maybe top, yeah, well, the top 5 one was the hexagonal box of chocolates that fit snugly inside the rectangular square, whatever it was. Yes, snugly, yes. This is right up there. We got the old marching band coming up. All right, anybody in here? We got band people in here? I just asked because I envy you guys because my musical talent ended in 5th grade after a year of playing the baritone. So I envy you guys, all right? Band camp kids, so nice job. In case you were wondering what right, left, forward, and backward were, I put little arrows up there for you. Okay, 2 questions. First one, as I go from position 1 to position 2, in your own words, what's happening? And then take your words and put it into function notation, which is what we talked about at the beginning today. And then in part B, you're going from position 1 to position 3. But I want that rule in vector notation. Heads up, look at your X and Y axes. Anybody see a little something different than we're not accustomed to about the X and the Y axes? It's going by a difference than 1, right? They're going by 2, so be aware of that when you tell me if I go right, left, up, and down, how many. So go ahead, you can work with somebody around you by yourself. So part A, you're going from position 1 to position 2 in your own words and function notation, and then part B, 1 to 3 in vector. So I'll give you a little time to work on that one. Let's go. Here we go. In your own words first, as I go from 1 to 2, in your own words, direction and distance. Oh, here we go. 8. Oh, thank you. Yeah, one job. Be here. 10. Left 12. Yep, and that was it. Left 12. Function notation, x, y. If I went left 12, how do I show that? X minus 12. Now you have 2 options here. You can just write y, because I didn't touch it. Or you can do plus 0 if you want to throw the old 0 on there. Either way. Minus 0. Sure. I'm sorry. A third way, Mike. Yep. Plus or minus 0. Yep. If you really wanted to be hardcore and show off. Yep. All right. Now we're going from 1 to 3. 19. Finish this strong. Which one comes first? You are correct. Which one's going to come first? Is that on the x-axis? X-axis always comes first, Kaylee. So which way 12? Left 12, so what do I got to put with it? Negative 12, and then you said down 9, right? So how do I show down 9? There you go. A reminder on the homework, graph means, now if you look on the homework, it says graphs are optional. That's for 18 and 19 only. 5 and 6 are not optional. Okay, that is for 18 and 19 only, that if you don't want to graph, you don't have to. All right, but 5 and 6 are not optional. So let's get going. You get a lot done here in the next 15 minutes. Let's act mature about this, please. No one's moving around. You're staying right where you are. No one's moving.